No. Let's see if I deserve it a little bit later on. I guess there's not much to do on a Tuesday night in Brisbane since you're here. So, but I really appreciate you coming. It's really good to see. Some of you I've known before, some of you are new. Great to see you all again. I would love to share a little bit about what's going on in Europe. That's what I've been invited here to tell you about. So I've divided it up in 3 subjects, which you all clearly see on the screen. So I would like to run through some of these things. It's true I've been in lighting for ages, and I work together with various standardization and all that stuff around the world. But in this case here, I would love to tell you a little bit about biologically effective illumination, should you find that interesting. Up here in the dark area, we see the LED and the glare challenge, because LEDs are behaving differently than other light sources when we talk about glare. And finally, down here, I have something I call the beauty of ambient lighting, where I just try to push the message that it's great to have vertical surfaces lit like we have over the coves here. It creates sort of an ambient. So I could go over here. The question, what do you girls want to hear about? You make a pick?
The first one.
The first one, that one?
Yeah.
Okay, good. So I just want to, now I'm among friends. I'm an electrical engineer, and I guess there are 1 or 2 engineers here as well, right? Good. So that's why I jump into the DIN-spec. The Germans released a norm in Germany here in 2013 in April month, where they talk about biologically effective illumination. It's only available in German, so I've done a little translation, and I tried to make it a little more popular. It's 68 pages, a lot of German standards. But the issue is that it's the first time they put in print how much light do we need in various situations to create a biologically response from our body that we actually can measure. We use the cortisol and the melatonin level as markers for our sort of alertness and our how awake we are. So if we have a very high cortisol level and a low melatonin level, we are awake, live and kicking, creative, happy, handsome, whatever, all that stuff. And when the daylight fades away, the balance slowly switches. High melatonin, low cortisol, we get tired and we fall asleep. So that's the chemistry. What we have been wondering is, what does it take? How many lux, how many candles, what does it take to create this biological effect? So if I jump into this, I'm sorry for my explanation. Some of you will probably find it childish, but anyway, I would love to go through it. It's all about the eye. Once we go inside the eye, we have our receptors in there for the RGB receptors, our rods and cones that most people know is connected to vision. But a part of our cells, like junction boxes in there, called ganglion cells. And these ganglion cells are photosensitive, or 3% of them are photosensitive to blue light on a wavelength of 460 nanometers. George Brainerd published his papers in 2003 where he talked about this, and it's been known since then, and research has just exploded around the world. So we know a lot about how much light we need and what wavelengths does what to our body. If we have to tell this to people who are not in the lighting industry or not lighting nerds like myself, we have to do something else. So normally I have a Danish coin, a Danish 2 kroner, has this size here, and I normally show this is the size. The interesting thing about this is not the coin's value, it's the size. It has a diameter of 24 millimeters, because that's exactly the same diameter as our eyeballs. So when we actually just see through our eyes, we have a pretty big eyeball inside our skull. So when we look a little bit closer to the eyeball, we watch the world like in a cone, sort of like, if Mickey Mouse goes around with a flashlight, it's always like this cone in front of him. And when you have to push these kind of messages, we have to work with steradians. And steradians is like an angle where we have degrees, but as soon as we start moving in space, it becomes a cone, and the measure for angular cones are steradians. So looking more like engineers, we would look at a cut in a sphere like this. So we have the area cut out here, and we have the radius, and the omega is the size of the steradian. So I trust you're more or less familiar with that term in illuminating engineering. But we don't use it that often. So if we start looking a little bit more at the eye here, you will notice that if we imagine we're looking at something out here, like standing here, and it goes through the lens, it focuses on our fovea in the back of our retina. And our sharp center vision is about 2 degrees. That means if you stretch out your arm, you look at the size of the nail of your thumb, that's approximately your sharp center vision. That means that if I'm looking at you, the other guys around you get blurry because I only have a 2 degree sharp center. If I want to look at you, then the other guys get blurry. That's how vision works. That's why when we read a paper, we move our eyes. We're not just opening the paper, sitting like this, and reading the entire paper, right? So we have to remember that there's a lot of eye movement going on whenever we focus and when we use our visual tasks. So if we imagine that we evolved somewhere in Africa or in the open glades or here in Australia when people were living outside in the wild, they were looking at someone here, and during normal daytime, the entire sky above them would like be a blue dome. So this area up from between these 2 angles, if that's a cone, it has an area of 0.5 steradian. And I'm coming back to that area in a little while. What is interesting is that during normal work hours or during normal daytime, you would focus on something here and the entire blue sky would reflect down to the bottom of your retina below the horizontal level, and this is where we have our ganglion cells. So in this area down here, we call it the ganglion cell area, which is 14 millimeter. It's pretty big when you think about it's an area inside your eyes. If we twist the ball and look through the lens, we will have the ganglion cell area located under the horizontal line. Each one of these dots will be 14 millimeters in diameter, so it's a fairly big area down here. Within this area, we have a concentration of ganglion cells. There are around 3,000 of these ganglion cells that are photosensitive to blue light, and they all have to be activated. It's not enough that you activate half of them. That will not trigger the biological response. You have to make sure that all of them are uniformly lit. So it's a pretty good, you need to have like the entire horizon, the entire sky lighting up the bottom of your retina. Does that make any sense? Nice. Thank you for nodding, gentlemen. So when I'm working in my office in Copenhagen Harbor, I have a wonderful view out here, and most of the time I'm just sort of gazing out to be inspired, and I have a horizontal line that are following my gaze. So if I want to find out whether this triggers a biological response, I need to take a luminance camera and take a luminance shot of my view here. And if you imagine this area here is the one that's going to be projected on the bottom of my retina, so I'm of course interested in the brightness of this area. If we look at the red one here, we are somewhere around 7,000 candelas per square meter, and if we are up here in the green area, we are down to around 3,500. And that's a lot of light. It's very seldom that we experience these kind of brightness levels inside, not even on a VDT screen or anything else. It's really, really powerful, and it sends a powerful signal to our body. It's daytime, it adjusts our mood, our body core temperature, our digestive system, and our well-being. So we're in fully operational mood. We are alive and kicking, awake and happy. But I'm not allowed to look out the window all the time. Once in a while I have to do some work, and this is my office space where I'm lucky. I'm having a window row with shed lights coming in from the south actually, so I have more than enough light here. I have bright areas in the window, I have bright areas on my office, and if I take my luminance camera and takes a shot at this, sorry, this is where I work, and to talk about the size of these 0.5 steradians, I made a dish out of polycarbonate and got a guy to cut it out and put these circles on. Because if you have a radius of 50 centimeters, that's when I stretch out my arm, and I put a dish with a diameter of 40 centimeters in front of me, whatever I see through this area is one of these dots that are going to be imposed on my retina. So I need it in this side of the vertical line, but I also need it over here. So it gives my customer or my clients a pretty good feel about the area that has to be lit. And according to the German standard, it has to be lit to an average higher or equal to 100 candelas per square meter. So it's achievable, but it's not easy. And we now know that in order to activate all 3,000 ganglion cells, it's not enough. It won't work if you only light up 0.1 steradian. That's sort of the critical mass. If you're above that, it will start to work. and it works 100% if you're out to 0.5. So it's not good enough that I put some small blue flashlight or something over here, or I highlight this area or use this and flash it directly into my face. It won't work. You need to have the entire area lit up to 100 candles per square meter. So if I do take my luminance camera here, you will see the yellow color from the window is around 700 candles per square meter. The red is down to 177. And I'm not cheating you, somehow it's just cutting off. There's actually a 1 in front here. So it's more than enough to keep me awake. So I will not be tired during normal work hours. I will be alert and happy and positive and all the stuff you want to be when you're at work. So during the daytime, it's no big deal. The challenge is that if I wanted to be active during the night, I need a very different lighting installation. So if we look at a nighttime shot where the sky is dark and the surroundings grows dark, I have lit up a wonderful fixture there with all the good things you can say about that. But that will give me around between 500 and 600 lux on the vertical surface. That's more than enough to work on my computer. It's more than enough to work in my office. But the question is, does this keep me awake during the night? So we grab the luminance camera once more and take a luminance shot of that, and you'll see the values here. The blue or the pink or the lilac one are all the way down to 2 to 3 candles per square meter. We're not even close. If we look at the brightness of the surface of the fixture here, it's around 500 candles per square meter. So we actually need brightness levels in that area. So this is a good lighting design, but it's not a biologically active lighting system. So what I'm bringing to you guys is that if you have to quote it, you'll probably have a benefit of reading the German standard or understanding the size of it and the brightness of it, because now you can actually be held accountable. People start talking about biologically active lighting or dynamic lighting or color changing and all that stuff. But this is particularly about a lighting level that creates a shift in your hormone level. So this is a unique thing, and color change has nothing to do with it. It's only intensity. It works with 2700, it works with 6500 Kelvin, so there's nothing connected to that. If you choose lower lighting levels with warmer color temperature, it's an emotional thing. A lot of people like that, and when we boost it to like 1000 lux, it's clear that we want, or very often we want, 6500 Kelvin to sustain that, just to make it feel right. So the debate was going on, are we really ready to release those values? Because within Fagerhult, we believe that 80 candles can do the job. But we are not really sure, so we have been hesitating a little bit, and then the Germans release it heavily powered by Philips and Osram, and they say 100 candles. And when I traveled down and spoke to them, well, they say it's better that we put up something now, and then we assume that it's right. And if we found out we can do with lower levels, we'll just revise the standard. So this is the first shot, if you should choose to use it. It's the first shot of a standard that tells us, but it suddenly takes biologically active lighting seriously. And it's a big step forward for lighting design, I think, that we can actually make environments that makes people feel alert and happy and whatever we can do. So I hope that has just given you a glimpse into biologically active lighting systems, and that we can make the first ones together, maybe. I think. Thank you very much. Thanks.